Additional funding was provided by Symbolics Inc., a major manufacturer of symbolic processing systems for developing and running complex software. And by these companies and foundations.
Probability is determined by the chance of receiving a specific outcome out of a set number of events. In the case of this deck of cards and the probability of drawing an ace, we know that there is a set number of 52 cards, or 52 events. The specific outcome we're looking for is the drawing of an ace. Since we know that there are 4 aces in a normal deck of 52 cards, we know that the possible outcome to event ratio, or the probability of drawing an ace, is 4 out of 52. Now let's take a look at probability in action by observing another simple random phenomenon like the flip of a coin.
To see how probability works, let's flip a coin. So I have 2 coins here. I'll be flipping the 2 coins to see what are the odds of getting heads and tails. So coin number 1. I got tails right now, so 1 tails, and I don't know about heads. Coin number 2. I got 2 tails. This must mean I have a 100% probability of getting tails, right?
Obviously, this guy does not understand probability, or he would know that his test is completely flawed. To understand probability, one must understand that probability is only useful in predicting long-term patterns, not individual outcomes. This is the signature of randomness. Randomness does not mean that an individual outcome can be predicted every time, nor does it mean that every event is chaotic. Randomness means that in the long run, a distinct pattern can be observed over multiple trials. Probability is simply a mathematical model for predicting randomness. As we can see, the probability of getting heads or tails with a flip of a coin is 0.5 or 50%. With one flip of a coin, we cannot determine whether or not the flip will be heads or tails. But as we flip the coin 10, 100, or even 1,000 times, we should observe the long-term pattern of about 50% ending up being tails and about 50% being heads.
As we can see, we conducted 3 trials in flipping a coin 100 times. In the 3 trials, the number of heads we got were, in trial 1, 47, in trial 2, 45, in trial 3, 58. On the other hand, the number of tails we got was, in trial 1, 53, in trial 2, 55, in trial 3, 42. As we can see, the total number of events that occurred for both heads and tails was 100, because of course we flipped the coin 100 times. And each number of heads and number of tails that we got was roughly around 50, because the probability of getting 50 heads and 50 tails is 50%. Because of variability, we did not exactly get 50, but as we can see, the more trials we conduct, the closer the average is to 50 for each, because that is the probability.
Hello and welcome to Anderson's Casino. Here, players will roll 3 die and see if they can call the total correctly. Players have many different strategies or betting options that can improve their odds of winning. If they choose, they can earn more money by betting on only one possible outcome. On the other hand, they can earn less money but improve their chances of winning by betting on 3 different possible outcomes.
You might wonder, what would a player use in order to find which outcome they should bet on or how they should play the game? Well, what they can use is a probability model in a form of a data table or a Venn diagram. A probability model is a mathematical representation of a randomness phenomenon. It is defined by sample space, events within the sample, and probabilities associated with such events. So sample space, denoted by S for probability model, is the set of all possible outcomes in one occurrence. If we take a single dice from Anderson's Casino and construct a probability model of the possible outcomes of the dice, this image, as we see, is what we get, this table. So the sample space is 1, 2, 3, 4, 5, and 6. In other words, the numbers from 1 to 6. The probability of getting each single number is 1 in 6 because this is assuming we have a fair die. In order to construct a probability model, we must take the possible outcomes and keep them on one side and keep the probability of that outcome occurring on the other. So in this diagram, we have numbers as the possible outcome and the probability of getting each number on the left as the probability of getting the outcome.
Let's go to the whiteboard to look at 2 basic rules of probability. First, the S in brackets denotes the sample space S. Rule 1 states that the probability of any event or outcome lies between 0 and 1. The second rule of probability states that the probability of sample space S is equal to 1. The examples that we have seen in this video of flipping coins, rolling dice, and drawing cards all illustrate the basic rules of probability. Hopefully after watching this video, you've begun to understand the basic concepts of probability. Though probability is difficult with many aspects to understand, hopefully these rules break them down for you. In our next program, we will be diving deeper into the more difficult concepts of probability. Thank you for watching, and until next time.
Swing